And Harbir Singh?
Yeah, Harbir will also join, please. I have just informed them.
Okay.
So we can wait for 2-3 minutes more, sir.
Okay.
Scheduled time is 10:05.
Yeah, no issue.
Good morning, sir. We'll be waiting for a few minutes, sir.
Yeah.
To join people, because this is a parallel session, so some of the people will be deciding that which one to join.
Okay.
Harbir Singh has joined in Hall B. Sushant, can you tell him to join in Hall? If he joined in Hall A, ask him to join in Hall B. Sushant?
ये अभिलाष किधर का है? कुछ यूनिवर्सिटी का है क्या अभिलाष?
हाँ सर। सर आपके इस सेशन में सारे प्रेजेंटर है।
नहीं, अभिलाष नहीं है।
लेकिन उन्होंने सर ये भेजा है। पीपीटी तो भेजा है सर। मोस्ट प्रॉब्ली वही है, ज्वाइन लिंक सर दोनों है ना सर।
हाँ, थोड़ा कंफ्यूज होता है।
Still joining. Sir, we can start now, otherwise we'll be late little.
Okay.
Welcome to this third day parallel session, the Hall B. And today, to coordinate this session, we have Dr. D.S. Pai. He is one of the eminent scientists in India in the field of meteorology. He is presently the director of the Climate Institute of Climate Change, ICCS, Kerala government. But he is mainly very much known to all of us as an IMD and one of the best scientists in IMD produced. So he was actually co-leader for the WMO Task Team Regional Climate Outlook Forum, and then he also member of WMO CBS expert team. Not only that, he is also co-lead or members of so many other expert team of WMO. then he is the main contributor of the SASCOF, that forum, and now presently he is very much involved in the IMS activity, and he is also recipient of IMS award. So, sir, it is honored to be honored to have you in this session to coordinate. So there are all lecturers are available as per official communication. So please, sir, try to maintain the time, because after that today we have actually poster session as well. So that's why we have to be stick to time. And questions, some of the questions will be directly asked through this WebEx, and some of the question may come from the online YouTube. So that question will be passed to you from by our organizer. Sir, now over to you, sir.
Thank you, Anandas, for a nice introduction. So without wasting any time, because we already consumed, I think, 4 minutes, we are delayed by 4 minutes. So I'm happy that all the 6 presenters are there actually. And as you know, there will be each presentation will get time for 10 minutes and 2 minutes for discussion also. So all of you, please control. Try to stop your presentation within within 10 minutes, complete within 10 minutes. So straight away I will invite Dr. Rajan for his presentation on characteristics features of hourly rainfall over plains and complex terrain regions. To Dr. Rajan, please.
Sir, please unmute you.
Please.
Hello. Yes, Dr. Pai. Hello.
Yeah, please,
Yeah.
Dr. Rajan, please share your
Shall I carry
presentation.
on? Yeah. It is like this. This is a slight introduction. If you listen that our yesterday evening talk by our Dr. Rajavan, former secretary, he has started that the monsoon mission monsoon mission has been last 2012 onwards. It is there. When he is mentioning about the importance of scale, he said that all the scale this monsoon mission has to be studied in depth. Then is starting from diurnal to seasonal scale, up to centennial scale, it have importance. So this study meant for diurnal scale. In this case, our mission NCMRWF is having a strong link with the major mandate of is the development and improvement of weather prediction model to India Meteorological Department to underpin their forecasting capability. In this, as of now, last more than 3 decades, NCMRWF is having the real-time operational analysis and forecast and dissimulation system of 2 model, which is of unique up till now. In this case, we are blessed with 2 global model, one from USA NSF base, another one is from UK, that is NCM. In this case, this study has been conducted for more than 2-3 decades. So how we have approached it? Earlier, the study was there, depending the diurnal scale, depending upon that amount of the data availability, amount of the space-based observation or ground truth. Throughout it has been done it is a research for many number of years, but there are some limitations depends upon that resolution and amount of the data and the quality of the data. They are restricted, but in our case we are, as of now, we have 2 global model and 1 regional model also it has. we have. These are the data set I used it. These are the formal notation I am going to have it. NCM meant for NCMW global model. These are well aware. Many people are aware of this one. NCMG, NCMR. Then we have 2-3 space-based observations which are available from TRIM. TRIM has served a quite number of long days. It has proved its capability more than it has served more than its time period also. In this case, TRMM we have, and JAXA. There are two types of JAXA. One is from USA, another one is from UK. Both of them has been utilized in our study. Then our GPM, Global Precipitation Mission, also we have some metrics. I have chosen it. This rainfall, rain frequency.
Sorry for
Study
interrupting.
motivation is. Yeah.
Rajan sir, actually you didn't share your presentation.
Oh,
So
sorry.
shall I
didn't
share
share the
on behalf of you?
Okay, please. You were told, sir. Yeah, please carry on.
Dr. Rajan, I had told you that you said you are going for introduction.
Oh,
Yeah.
no, sir.
That's what I am also got confusion.
By the time that means my time is 10 minutes start from now only, sir. So these are the data set I used in this study. So NCMG, NCMR, there are two the JAXA and GPM. Next, please. Hello. Yeah. This is the famous slide we have. This shows the suite of model. As of now, we are having it with the global model, global scale, and some of them, and the two global scale model we have, and the NCM of 12-kilometer resolution, and after the regional model of 4-kilometer resolution, when because the need we have made it the 1 kilometer, then 330 meter and 430 meter. Next, please. Yeah. In this case, our study has started very long back when 2013, when we studied, there are two plots in that one. Upper plot have only observation, this is trim observations, and the lower one right more XMS, this is NCM model. Here, the first fly is that that upper thing, if you see that one, almost it matches with the daytime rainfall, and lower panel matches with the nighttime rainfall. So the same thing is repeated in my frequent subsequent slide also. Here, what I mean is the message is that if you see that observation, there are 0 to 12, it is in the upper panel. Maximum of the rainfall is supposed to rain. It is raining it also as of now over the core monsoon region during 06 to 09 of UTC, which has been highlighted here. So if you come to the model is start raining little 3 to 4 hours earlier than observations. This is the message I want to brought it, and it was highlighted also in this place. It happened in NCM model. Here you see it start raining more 0 to 3 UTC, and it is subsequently spreading to 06 to 9 UTC also. This is the single plot I have. This is 2013. So next, please. Hello, please. These are for this different region wise. I have chosen how this total amount of rainfall it has. Suppose in the case per day we look into the model. Up to now, we are having the daily rainfall of, suppose it has 20 centimeters of rainfall, it occurred within 24 hours. So if it is occurring even all 1 hour for 1 centimeter, it has sort of different. Suppose it is all the 24 centimeters of rainfall, it's occurred over that 1 hour, that intensity is suffering it. So intensity matter out there. So as far as we are concerned, I am concerned for the modeling study. So intensity matter rather than duration also. So these are the different region I have selected: ocean region, land region, and continental region, monsoon region, equatorial region, foothills. So these are the study is coming up. Next part, please. Yeah, this slide shows, this is simply XY plot saying that upper panel, there are two lines over here. The green line shows that NCM model, it is raining, it maximum amount of rainfall is occurring 6 UTC. Below one is that blue color one is observation, trim observation, space observation. So in this case, trim observation is having maximum around 13 to 12 UTC, but whereas in the model it is raining having minimum over 12 UTC or 13 UTC. This meant for the 2013. Next, please. This is all season onwards. So my yes, please. Next, it is not. I have chosen for 24 hours forecast. Then it is only foothills of Himalayas. Foothills of Himalayas, it is a little less. Next, please. Yeah. This is also 2013. Here I put that GFS also. This is my older study. So during 2-3 years of that one, I used to collect that hourly rainfall meant by the NGFS and the NCEM. This has been archived for many number of years. So in this one, regular meant for GFS one. If you compare with the GFS with the observation, almost there is a match with that one. If you go for the NCEM, the metafish model, there is a phase shift. It has been documented in many places. Next, please. Please carry on. Yeah, this is the same thing. Not only 24-hour forecast, that's 48, 72 hours also it reflected. Next, please. Please go ahead, sir. Yeah. Here, what I mean to say is that different resolution, day 1, day 2, day 3, day 5, up to day 10, I have did it. According to length of the forecast, this minimum amount of rainfall, the phase minimum amount of rainfall is occurring over 13 UTC only. Next, please. Yeah, this is a particular one. When we come to the regional model, 24 hours is the rainfall. If you see it, there is a spinner problem over there. It is very clearly brought out that so it is stabilizing after 48-hour forecast only. It has brought it. It has been documented. Next, please. Yeah, this is for the period of 2016. Next, please. I will say what it is. Sure. Carry on, sir. Yeah, here what it is 2016. I have chosen the heavy number of heavy rainfall events and the less number of events for the month of June. If you take the regional model and the GPM observation, here you see the upper panel of the 0 to 3 UTC rainfall is almost nil or least amount of the rainfall it has brought. So it is validated with the geographical distribution as well as this computation also. It has reflected compared to GFS. GPM. This result is shown here. Yeah. This is the famous one. It is taken only the land. Here, what it did is that maximum amount of rainfall I have chosen up to, I fixed some threshold value. Then I have taken that heavy rainfall days and less number of days. Then next, please. Here I have chosen among the 122 days, I got 25 days, which has here up this left-hand side panel shows the high amount of the rainfall and the lower amount of the rainfall. If you see the only heavy number of heavy rainfall days, if you took it, the shift is seen even 0 to 3 UTC also. Yes, next the message is that if model is start raining those days, if that heavy rainfall days is if you choose the heavy rainfall days instead of 6 to 3 UTC, it start raining ahead of the 3 ahead. So next, please. Then this result is carry on next, so this is only
Dr. Rajan. Dr. Rajan, you can conclude now. Your time is over.
Conclude. Yeah, carry on. I will tell the where I stop. Yeah, please carry on. I will come to the conclusion. Only text I will be showing it. Yeah, yes, sir. Here you got 2007 heavy. Yeah, carry on, please. I will come to the conclusion. Only 2 slides I have, sir. Yeah, play 1 minute. Here, what I will say. Yes, please stop here. Here, I want to say. So when I see that one, climatologically, if you see all 24-hour forecast, western coast having some maximum amount of the rainfall for the whole monsoon region. If you count the number of rainy days, what is happening? It is the number of rainy hours which is occurring in the west coast and foothills of Himalayas. Yes, carry on, sir. Foothills of Himalayas is more number of rainy days when compared to west coast. So this is the particular day of continuous amount of the continuous number of days. In this case, this plot is showing very good information. The number of rainy hours and the amount also. Next, please. Conclusion in comes, sir. I'm going to close it. Yeah. Here, yes. Conclusion. Yeah. Conclusions. Yeah, please be. Next. The dynamical cycle of the rainfall over inland orography is different from coastal orography. Here, what I mean to say is the distribution over the west coast is different from the distribution of the rainfall over the Himalayan region. It is well brought by the GFS as well as NCM also. Yes, there are different physical parameters as occur in it. We are examining it. The result is that whenever the maximum amount of the rainfall is occurring, it is almost matching with the surface temperature almost the same time, along with that, the humidity also, moisture parameter also, it is occurring. Yes, answer. Next. The same study I have repeated for IMDA data set for 40 years of IMDA data set we are having it. It has been archived hourly. Yes, please carry on, sir. Next. You come to the last one. Yeah. Carry on. Next.
Thank you.
Next. This one is next. Yeah, please stop here. Yeah, let it be. Here, what I mean to say is, when there was a heavy rainfall occur over that Kerala, during the month of 2018 August and the 2019 August also, the study has been completely done. It has brought that whenever this kind of heavy rainfall is occurring, there is no diurnal cycle is observed, as well as observation along in rain gauge also, space observation model also. That's
Okay.
all I want to say.
Thank you, Dr.
Thank you.
Rajan.
Please,
So
I
you
welcome
have-
I welcome any number of questions in that one. Please.
Yeah. So anyway, so there is a, you have already consumed your time for question also.
Yeah.
So I don't think
Yeah.
that we have got time for question for your thing. We will move to, thank
Ah.
you for nice presentation.
Okay.
We will now go to the next
Thank you, sir.
presentation by Dr. Harveer Singh.
Okay. Thank you. Bye.
Thank you, Dr. So, Dr. Harveer Singh, you can start. So all others mute your mic actually. Dr. Harvish, you can project it, Harvin.
Hello?
Yeah.
Yeah,
You can
am I audible?
project it. Come to first slide.
Okay. Yeah. Yes, good morning to all. So I'm presenting here the multimodal spatial verification for rainfall forecast during recent monsoon.
So sorry for interrupting. You are not in the first slide. Yeah.
Yeah, I am able to see first.
Yeah. So this is the first slide.
Yes, please continue. Start.
Okay. So I'm going to present the data I have used. This the IMS rainfall observed in NCM, UPMO, GFS, NSEP, and ECMWF methodology, and finally results. So here data I have used is IMS, which is available half hourly, and we have accumulated to the daily 3 UTC to 3 UTC. And the forecast data we have used for the multiple models, and this is also regraded to the observed grade, that is the NCM, UPMO, GFS, NSEP, and NCM, ECMWF. So the motivation for this object-based diagnostic evaluation is that like which forecast is better. In case A, these are very close, and case B, these are little bit far. And this language, in case of C, this is slightly that is one is flat and another one vertical, and in case of D, it is round shape and another one is like oval. In E case, it is slightly overlapping. So here we can see the scores comes A to D is approximately totally 0, and false alarm is 1. So in case of E, it is giving some scores. So that is correlation coefficient, probability of detection, false alarm ratio, and all these things. So this gives. So it's give that motivation to us, and finally come to the this methodology. There are the 4 steps to do this. So first one is the original data we have stored in this methodology. Then second one is we have applied some conversion threshold, and third one is the mask that particular threshold or region, and final step is the filtering out and accumulated for threshold and computing some stats using fuzzy logic attributes for things. It finds some attributes, interest maps, confidence maps, weights, and total interest. Object attributes also like single or pair wise. It will compute pair wise and single object wise also. So here is the one score is this the median of maximum interest. It is showing we are having 2 observed object A and B, and the 3 forecast object 1, 2, and 3. So it compute each and every object wise with respect to the forecast and observation some interest matrix. Then finally we will compute the median of this interest. So that's why it's called the median of maximum interest. Now the object is here. So the left panel is top left is showing the forecast, and this one is observed object, so it is creating some object. So and the Gujarat coast, the Gujarat region also, Gujarat or Rajasthan region, it is showing some blue patch, and this is the false alarm. It is not observed in the observation, but it is in the forecast. So finally, the right panel, we can see the circle area. It is the red patch is it's like forecast object, but observed object is slightly southward. So it is some part is matching. So that's why it is giving some stats in the lower side. Stats. So it is giving median of maximum interest for individual also, like forecast and observation, and the combined also. Like forecast and observation, it is giving 0.87, and some threshold values we have given here. It is given, and finally it is giving some stats with the cluster wise. So cluster wise, like center distance, angle difference, forecast and intersection of ratio, union of this and these things. Now coming to one example I'm showing here for all 5 models. Like this is for 60 millimeter threshold, 27th of August 2020. And we can see the observation. This is the green patch in the NCM case. So it is even forecasted up to day 5. So this patch, but UCAM also up to day 5. GFS is up to day 3. It is day 2. It is forecasting, but it is slightly northward. So this is actually not matching with this one. But model is predicted that particular value, but it is slightly northward. And the other 3 days, 3, 4, and 5 days, this event is not captured. So this is the missing event. In case of NSAP, only the day 5 is missing that event. And this blue patch also in the NSAP, it is getting slightly the southward. Anyhow, it is predicted that event, but slightly southward. So this ECMWF also predicting for all 5 days. So in that order, so we have gone through this angle difference. So angle difference is the minimum of both the objects observed and that should be minimum, and for forecast and observation objects. So here we can see the first is threshold, like convolution threshold is 20, 80, and 120 millimeter. So in case of 20 millimeter, we can see that the nearly this ECMWF and NCMRWF, this NCM model is UCAMO, approximately predicting the same angle difference. Then we can see the 80 millimeter threshold. It is slightly less, like it is compared to the other models, it is comparing less, and going beyond 120, 100 millimeters. So it is again some values is increased, but yeah. NCMR, this NCM is giving still some better scores for this one. This is for 2020 results for this one, showing the same type of results. Now coming to the area ratio. Area ratio is nothing but the provides an objective measure of whether there is an over or under prediction of real extents of forecast, and close to 1 is good, perfect score. So close to 1, here we can see approximately all the models is showing around 8.8. Values maximum, so it is quite good. As long as like this convolution threshold is increased, these values varies model to model. And here is like 120 threshold NCMWF, and this ECMWF is slightly good compared to other models. In 2021 also, it is seen like it is less than 8. In 2020, it is 0.8, but in case of 2021, it is slightly less than 2021 place. It is showing same kind of results like 2020. And central distance also, that should be minimum and provides a quantitative measure of constants of spatial displacement of forecast. Here, small is good. So small is we can see the is small, and this part is like around 5 grid size. So it is minimum side. We can see the 2020. It is more or less same, but some models it is giving slightly higher values. So for UCAM on day 1, and another like we can see the 120 threshold also. This is varying with the model, and same type this center distance can be seen in 2021. Some values GFS is showing very less, so it is quite good for like 120 threshold. And symmetric difference is like maybe good to some statistics for how well forecast and observed objects match, and here also small is good. So is we can see it is nearly it's 50 or 100 within that grid squares are all the models up to it is varying for 20 threshold, 20 millimeter threshold, so up to 400 grid squares. And after that, as long as this.
Dr. Harvish, you can, you can.
Okay,
conclude.
I'm concluding on this one. So this finally coming to the total interest. Total interest is coming to the close to 1. So close to 1 is 20 millimeter. It is nearly close to 1, and up to 120 threshold. Same type in the 2021 also. It is 0.95 somewhere, and these models. Now the system, the object-based verification is highly intense. Rainfall well forecasted for up to 5 days, and angle difference, center distance is minimum, and area ratio is maximum for 1. So thank you.
Good. So it's a nice presentation and a new method of verification of spatial distribution of rainfall. So we can have a quick question. Anand, you want to ask some question?
Thank you, sir. Harbir, actually, I have two questions actually. One is that what is the matching criteria you used? That matching algorithm means when you are telling forecast and object and observed object is matching. What is the criteria?
What criteria? Criteria actually we are considering here the threshold values for rainfall. Like 20 millimeter, I consider first value, then second value for 80 millimeter, and then 120. Some higher values, some lower values. So
No, that is the brain threshold. I am
threshold.
talking about the matching criteria. When I am telling this forecast object is matching with the observed object. Because
Okay, so here actually one operator also applied. There is a convolution radius.
yeah.
So that is here 2 grid square. So I applied for this one. Within that range, it is under this rainfall is matching. Then it will make an object.
Okay. Another question is that you showed that different threshold displacement is different. That is fine. But what is the actually size of object that with a ratio that should be with the ratio of the size of the object. Suppose your object size is very small,
Okay.
then displacement will be more. Certainly, displacement will be more. That model is not predicting that. But if your object size is very large, displacement may be very less. But so that way it should be with the ratio of the object size.
So actually, I have shown here area ratio. Area ratio is nothing but the forecast divided by observation, observed data. So
Yeah.
on this order, we can find out how much is its matching.
Yeah,
Okay.
so we have to compare the results along both the things, means area ratio along with the displacement.
Yeah.
Okay, thank you.
Thank you, Dr. Harvi.
Okay,
Very nice presentation. Now we will move to the next presentation by Dr. Abhilash on regional rainfall analysis of Haryana in relation to monsoon teleconnections and agriculture. To Mr. Dr. Abhilash. Abhilash, you can share your presentation and start. Dr. Abhilash, yeah.
Abhilash, try to share whole screen. Actually, if you try to share application, it will not be shared. Actually, it has some issues.
Am I audible to you now?
Yes. Perfect.
Respected dignitaries on the desk, a very good morning to all of you. I am Abhilash, working as project scientist at Agromet Advisory Service Division, IMD New Delhi. And like we know that monsoon rainfall contributes to about 75% of annual rainfall in most part of India and Haryana. And Haryana is a small state which comprises only 1.5% of rain. So it is an agriculturally important region in which around 86% of land is arable, and out of this 86%, 96% is cultivated. And there are years during which monsoon rainfall is deficient, which leads to decrease in food grain production. And so temporal and spatial variability in monsoon rainfall influences the agricultural productivity. So ENSO being one of the major external forcing influences the intra-seasonal and inter-annual variability of monsoon rainfall. So studying the effect of ENSO at regional level monsoon rainfall may be helpful in sustaining the farm productivity by taking decisions like crop selection during Kharif season and mid-season scheduling of rainfall in case of dry spells. So present investigation has been planned with these three objectives. First is to examine the regional rainfall distribution, variability and trends in Haryana. And the second was to investigate the relationship between regional monsoon rainfall and teleconnection. And third was to analyze the relationship between regional monsoon rainfall and food grain production. And this is the study area. The figure shows that Haryana come under Met subdivision number 13, lying in northwest India, and this black line, which is running through the state, bifurcates it into two agroclimatic zones, western and eastern agroclimatic zone. And the data set which I have used here are the gridded data sets of IMD of rainfall for a period of 40 years from 1980 to 2019. And surface temperature of NOAA, and the last was the food grain production data set of Haryana. And this first figure shows that monsoon rainfall received by Haryana in different districts, and it can be seen that highest rainfall was observed in the districts lying in eastern part of Haryana, while the lowest rainfall was observed in the district lying in western Haryana. And in the same way, second figure shows the variability in rainfall in different districts, and it can be seen that rainfall was more stable in the district lying in eastern Haryana, while it was more variable in the district lying in its western counterpart. And we have done the trend analysis using trend-free pre-whitening Mann-Kendall test, which removes the effect of photo correlation in time series if there is any. And it was found that districts have decreasing trend, but significantly decreasing trend were only seen in two districts. One is Kurukshetra and another one is Panipat, of more than 5 mm per year. And this is the list of El Nino, La Nina, and neutral years, which were identified on the basis of 5 consecutive 3-month running mean of sea surface temperature anomaly above a threshold of 0.5 degrees Celsius in Nino 3.4 region of Equatorial Pacific using the data of NOAA. And out of these 40 years, 7 years were El Nino, 7 years were La Nina, and rest 26 years were neutral years. Now this figure shows the deviation or difference in rainfall during ENSO condition from rainfall during neutral years, and it can be seen that most of the districts have shown an increase in rainfall during La Nina years and decrease in rainfall during El Nino years in all the months. But maximum decrease during El Nino years was observed in July, and maximum increase was observed during September in case of La Nina years. And similar result were noticed for seasonal rainfall. And this figure shows the distribution of number of rainy days during ENSO condition from neutral years. And it can be seen that most of the districts have received more than 5 extra light rainfall events during La Nina years as compared to neutral years, while a decrease of more than 5 light rainfall events was observed during El Nino years in most of the district of Haryana. Similar was the case of event in medium and rather heavy rainfall intensity categories, but frequency of rather heavy intensity category was comparatively higher as compared to the medium intensity category. And this figure shows the monsoon rainfall at most of the district has shown a negative but significant correlation with sea surface temperature of Nino 3, 4 and 3.4 region. But there was not significant correlations with the Nino 1.
What happened, Abhilash? Dr. Abhilash? Anand, we have lost connection, I think, with you.
Sir, I have sent a request for unmuting. He is in the meeting. Yes.
Hello.
Yeah.
Yes.
Abhilash, you can.
Sir, are you able to hear me now?
Yes, 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 please. But your presentation is not being.
Yeah, please put your presentation or.
Oh. Sir, I think the connection.
Disconnected.
Yeah, we can hear you actually.
Sir, I have joined from mobile for that, but I'm sharing again.
Yeah. So if you have problem, any problem, you can,
Yeah.
Yeah, it's very nicely seen. Please.
Yes.
These
You
figures
can
show the
stop your
distribution
video
of
so that
lower wind circulation at 850 hectopascal.
Yeah. Please continue. Please continue. Dr. Abhilash, we are not hearing you. You might be muted. You are muted, Abhilash. Please unmute.
Am I audible now?
Yes, yes. Please continue.
These figures shows the distribution of difference in surface moisture flux during ENSO years from
Yes, please. Yes, please. Continue. Abhilash, we are not hearing you. Your presentation is there. Abhilash, we are not hearing you. Abhilash, you are muted. We are not hearing you. Anybody else is hearing him?
No, sir, we are not able.
No, we are not able to hear.
Yeah, yeah. Dr. Abhilash, we are not hearing you. I think there is some technical issue. Dr. Abhilash has got some technical issue. We will. He has got 1 more minute. 1 more minute. Dr. Abhilash, we are not hearing you. Okay. Okay. Abhilash, your time also. So we will. Move to the next. Presentation. Abhilash, I am sorry. Actually, you can unshare. I think he is continuing to show conclusion. Hopefully he will.
Looks like he is not hearing anybody.
Yes, yes, yes. Dr. Abhilash, you can actually stop sharing now. Okay, thank you. I'm sorry that there was some technical issue. Now we will move to next presentation. So if at the end of our session, if there is a time left, we will call again Abhilash and we will have some question answer. So now we will move to the next presentation by Dr. Indira Rani on influence of aircraft observation in simulating the Indian monsoon features in the IMDA analysis.
Thank you, sir.
Yeah.
Actually, I request admin to share my PPT in order to avoid if any technical issues. So if they can share, it would be nice.
Yeah, yeah. Organizers, you can.
Yeah, organizers. Yes.
Great.
Thank
Please
you.
start.
Okay, so I will be presenting the influence of aircraft observation in simulating the Indian monsoon features in the IMDA reanalysis. And I have many co-authors. I have listed them. Next, please. So as of now, everybody knows what is IMDA regional reanalysis, and it is done under the National Monsoon Mission of Ministry of Earth Sciences, collaboration with UK Met Office and IMD at NCMRWF. And it is for initially for 40 years from 1979 to 2018, and further we extended to 2 more years to up to 2020. And this study we have done during 2019. And during the period of IMDA regional reanalysis, there was a considerable growth in the observing system. And this reanalysis is aimed at to improve the monsoon understanding of our monsoon features. Next, please. So this is the IMDA domain. It spans from 30 to 120 degree east and 15 to 45 degree north. And this is the currently highest resolution available regional reanalysis over the Indian domain. Next, please. So we have assimilated a large number of different types of observation. As we can see here, that surface, sonde and aircraft, these are the 3 types of observation assimilated throughout the period of IMDA. And apart from that, we started assimilating TOWs during the initial period, and after that we moved to the advanced satellite instruments. Next. So this shows what are the different satellite instruments we have assimilated. In the initial years, maybe up to 2020, we assimilated the TOWs. Then after that, we moved to the ATOWs, advanced TOWs. Next, please. So this is the conventional observation, that is the surface, sonde and aircraft observation we assimilated in the IMDA system. This is a snapshot of that observation assimilated representing one particular year from each decade. That is the 40 years, then each decade from that. So 1984, we were having a lot of surface observation, then sonde, and if you see, there is only less number of aircraft observation. And the number of aircraft observation, it is increased as we move forward. The 1994, it is further increased. 2004 again increased, and 2014, if you can see that there is a large number of observation assimilated over the IMDA domain. So next, please. Here we can see. So the motivation to this study is the outbreak of COVID-19 pandemic drastically reduced the availability of global aircraft-based observations. And there were many studies reported that some study by Chen 2020 reported that when compared against the reanalysis data set, large deterioration in the forecast of surface meteorology over the regions with busy air flights, that is over North America and South China and Australia. It is noticed due to the deterioration in the aircraft observation. And James et al. 2020 reported that the regional NWP guidance was degraded due to the lack of aircraft observation. But in the case of global NWP, the signal from the loss of aircraft observation data was not clear, because in almost all the global NWP centers, they were assimilating all the advanced satellite observations and also the GPSRO, that is the radio occultation data sets. So in the global NWP, we didn't notice that much influence of the aircraft reduction because of the advanced satellite data. But in the regional domain, many studies reported that because of the reduction in the aircraft observation, there is a degradation in the forecast. So previous studies of the impact of COVID-19 pandemic, it was mainly on over the heavy aircraft observation area. But in IMDA domain also, we receive a good number of aircraft observation, though it is comparatively less than compared to the heavy aircraft traffic regions. Next, please. So this is one snapshot of aircraft observation coverage received at NCMRWF. The left top is the 10th April 2019. Here we can see that we have a good coverage of aircraft observation. When we see 10th April 2020, that during the pandemic, the number of aircraft observation, it is reduced. Similar, the bottom panel shows the left is the 2019, 10th April. There also we can see that IMDA domain, there is a large number of observation, but we move to 2020, the number of observation, it is reduced. Next, please. Next. So this is just comparison. Here the left plot shows the time series of the 2019, 2020 and the difference. Here we can see that the difference is larger than the number of observation received 2020. So the pandemic affected the aircraft observation information, but the statistics are comparable. Next, please. But over the IMDA domain also we noticed a difference. That is, the yellow line shows the difference, and the yellow line is larger than the number of observation we received during 2020. But again, over the IMDA domain, we noticed a reduction in this O-B, that is the analysis and the background innovation statistics also. Next, please. Next. So this shows the influence of aircraft observation and other observation. Here the positive value shows the degraded information, and the negative value shows positive beneficial information. So here we can see that when we denied the aircraft observation, almost all the assimilated observation, that information is degraded. Next, please. Next. Here is this is the radius on the vertical profile. Here also we can see that the positive is detrimental and the negative is beneficial. So up to above 14 kilometer, we observed a detrimental means influence due to the denial of aircraft observation. But above that, we observed some little positive beneficial influence. Next, please. This is the analysis increment. Next. Next, please. So here we can see that due to the assimilation or the denial of aircraft observation, the main features are changes are seen over the upper level, that is around 14 to 17 kilometer, where we have the most aircraft observation during the flight level. Next, please. Next. So this is the monsoon, mean monsoon circulations, July to August 2019. So first panel is the LLG, and the second one is the TEJ from IMDA, data denial experiment, and difference. So if we concentrate on the difference, here we can see that the difference is mainly concentrated over the heavy air traffic area. So here we have heavy air traffic observations, aircraft observation, and the difference is mainly concentrated over that region. So this shows the aircraft observation assimilation has a good positive influence in the prediction or the simulation of alleged monsoon circulations. Next, please. Next. This is again the time series of low-level jet and tropical easterly jet. Here we can see that in the low-level jet, we didn't see much difference. If you see the difference, it is 0.6 meter per second only. But in the case of tropical easterly jet, we observed a maximum of 3 meter per second difference due to the assimilation of aircraft observation. So this is again that aircraft observations are mainly confined over the 14 to 17 kilometer or above the 12 kilometer level. So we can see clearly the influence of aircraft observations. Next, please. Here, this one shows the OLR and the accumulated precipitation during July and August 2019. But we didn't notice any clear difference in the OLR or the accumulated precipitation due to the denial of aircraft observation. But there is a slight improvement over the heavy air traffic area or the IMDA domain, but that is not statistically significant. Next, please. And we did some analysis of the cyclones formed over during the study period. So there were two cyclones, Maha over the Arabian Sea and Bulbul over the Bay of Bengal. And what we noticed is during the initial stage of the cyclone, like low depression, like that, when we assimilate the aircraft observation, the position error was high. But in the when the cyclone becomes strong and when it is in the severe stage, the error is reduced. So if here we can see that in the blue curve, that is the IMDA interim, and the red curve is the data denial experiment. So the initial stage, the data denial experiment, when we remove the aircraft observation, the position error was less. But in the severe stage, when the cyclone becomes severe, the aircraft information, that observation has a good influence in reducing the position error. So that is this similar characteristics we observed during both the cyclones, Maha and Bulbul. Next, please. Yeah, that is one. Next, please. So this is the summary. So the outbreak of COVID-19 pandemic, it is drastically reduced aircraft observation. And this study focused on the impact of aircraft observations in regional scale assimilation over the Indian monsoon region under the framework of IMDA regional reanalysis. And the IMDA domain receives a quite good number of ABOs, though it is comparatively less than over the heavy air traffic area. And the impact of ABO assimilation in the IMDA domain is analyzed by comparing the results from a data denial experiment and for a period of March to November 2019. And the comparison of the impact of ABO on the other conventional and satellite observation assimilated in the system shows that importance of ABO, particularly in the IMDA, since it does not assimilate the GPS RO and the latest satellite data, because it is for 1979 to 2018, we initially decided, but and we set the data assimilation system and the forecast system, and for the regional for any reanalysis, the assimilation system and the forecast model should be same. So we cannot change the assimilation system and the model in between. So we didn't incorporate the GPS RO and the advanced satellite data in the IMDA system compared to the global operational models. Assimilation of ABOs improved the upper tropospheric circulation during the study period, particularly the tropical easterly jet. And analysis of the features of the cyclones developed over the North Indian Ocean during the study period revealed that the ABO assimilation plays a key role in simulating the track and intensity of tropical cyclone when they are in the severe category. But in the low depression, in those category, we didn't see any positive influence, but in the severe category, we do see some influence of the aircraft observation. Next, please. Thank you. This is over.
Yeah, Dr. Indra, you have done a nice presentation and been within the time actually. So we have time for one or two questions. So before I ask others to ask questions, just I want to ask you, when unless you make a real-time IMDA analysis made available, whatever it's not. So I have been telling several times, you should try to make it on real time. So then only it will be, benefit will come actually. Continuous analysis for several things.
Okay, so that actually we are planning for that. The basically IMDA is 12 kilometer and our current global model is 12 kilometer. So again, running a regional model in 12 kilometer, there is no feasibility. So what we are thinking is we produce the similar product from the operational thing, and means as a continuation of IMDA, we will disseminate. That we are planning.
So that, yeah, please continue.
And in future, we may go for a even high resolution regional reanalysis, maybe 4 kilometer or something like that. Because otherwise, continuing in the 12 kilometer, there is no meaning, because all the NWP models, they are moving to 10 kilometer, 6 kilometer like that. So our plan is like that. So we are preparing from 2021 onwards the downscale product from the NCM global model, similar to the IMDA. So whatever variable available from IMDA regional reanalysis, everything will be available from these data set also. So I think maybe within 1 or 2 months, we will disseminate that data through our reanalysis portal.
So that will come, that means real time this data will come.
Real time, maybe 1 or 2 days lag with 1 or 2 days.
That is fine.
Yeah,
I think that is fine. That is a good.
Yeah,
okay, now, your upper air data, aircraft data, how that actually help you to improve the low level jet, etc. So mainly
this low level jet, we didn't notice much influence because there is only that difference when we assimilated the aircraft observation. It was only 0.6 meter per second. That is the strength difference. But it may be due to maybe some aircraft, maybe during takeoff, landing, that time they have the high resolution data. It may be due to that one. But in the upper level, that is the flight level, we have the continuous data from the aircraft relay. So that we are observing the most important influence on the tropical easterly jet in the upper levels.
So do all the Indian aircraft, private, everything, they are reporting, or
no, sir, no, sir, not all. Those aircraft with that AMDAR systems, those are only reporting. So I think we already talked to IMD, and IMD is in discussion with airport authority. Maybe they may include that AMDAR instrument in almost all the commercial or that passenger aircraft. Then it would be good. Then we also get a lot of observations.
Good.
And it would be, and even you suppose if you are getting all the takeoff and landing observation, it is equivalent to radio sound day because we get the high resolution observation during takeoff and landing.
Yeah, sir.
Yeah, Anand.
Actually, sir, all data are not free. Actually, some of the data we have to buy actually with cost. So some of the aircraft's data we are not receiving because we have to pay for that. So that work is going on, sir.
Okay, okay. So that will really actually help, I think, simulation as well as
Yes, sir.
forecast.
That even that will help for the boundary layer studies because it will be high resolution data.
Okay, thank you, Dr. Indira, for excellent presentation. Anybody have got a quick question? Last question. Okay, I think if there are no more questions, let us thank Dr. Indira. And thank you, Indira. We will go to
Thank
now
you, sir.
next presentation. Next presentation is by Dr. Sushant Kumar on machine learning approach to improve tropical cyclone intensity prediction of NCMRWF ensemble prediction system. To Dr. Sushant Kumar, please. Yes, Sushant. Yeah, you can share your PPT.
This fine?
Yeah, fantastic. You can. Okay.
In presentation mode again?
Yes. Come on. Start. You can.
Hello, good morning to everyone. So the top title, as you see, like this is a machine learning and a new work recently we have started at our center to improve the tropical cyclone intensity prediction of our ensemble prediction system. So the next slide, is this visible?
Yeah, Sushant, please. Move.
So before going into the details of machine learning and other aspects, let's start how our ensemble prediction system model is and how is the model is scaled. So just to brief, I have highlighted a few things about our system. So this is an operational system at NCMRWF, which has horizontal resolution of approximately 12 kilometers. And it has 70 vertical levels up to height of 80 kilometers. So we have very fine resolution, and this model has control run from our deterministic model, and for initial, and we do the initial condition perturbation for wind, temperature, humidity, pressure generated by ETCAP, and we run this for 4 cycles, 0, 6, 12, and 18. And the long forecast from our model we provide, we generate based on 0 and 12 UTC. And we have 23 ensemble members. So this is a lagged member. We run for 11 for current cycle and take 11 cycles from the previous model run. Altogether, it makes 23 members. So let's see what was the motivation behind this study. So if you look at the literatures and including the recent one also, so you can clearly see that people like forecasters and NWP modelers, they find that NWP models have improved their skill, but still the intensity prediction of by these models are still challenging. This has been reported in literature like report at 2012, then DMARIA 2014, and even the recent studies also highlight like evaluated in 2018. So even one paper we found like the National Hurricane Center, which is the operational agency, and they provide the forecast, and they have very long experience. When they compare 24-hour track forecast and intensity forecast, they have clearly highlighted that the improvement was very large as compared to what they found in the intensity prediction. When we look at our model, we see that the deterministic part, which is the control run of our ensemble prediction system, recently we have done this study, we have thoroughly investigated our NCM model, and we have found that the track forecast as well as the intensity forecast has improved when the model was upgraded in 2018. So in this figure, you can see that blue and red colors, the two different versions of our model, which clearly shows that the later version has shown improvement in all the forecast lead times. And these we can attribute to the improved data assimilation system and increased volume of data, and then higher model resolution. So previous model was at 17 kilometer and later one was at 12 kilometers. One interesting thing also we can notice is that errors in the intensity do not increase with the forecast lead time. So usually we see other parameters include the track forecast. We see that the track errors increases with the increasing forecast lead time. But this was very interesting, and this has opened the door for us when we were setting up our machine learning model. So before getting into the details of the modeling and machine learning techniques, we can see what all the aspects we can use in our NWP system. So as you all are aware, previously, even a few years before, you can see most of the machine learning models were data driven. Even IMD was using their monsoon onset, and that was a statistical model. But now the things have changed, and the researchers are focusing more and more how to improve NWP models and how to implement these machine learning techniques at different stages of modeling setup. So you can see machine learning techniques can be used at data assimilation, model physics, parameterization, and the post-processing. And most and the easiest way we can see is the post-processing, where previously also people were using. So our research is mostly focused on the post-processing part and how to use the machine learning technique to improve the tropical cyclone intensity prediction. A similar study of recently we have seen where Chan et al. Has used ECMWF ensemble prediction system, and using one of the machine learning algorithms, they have tried to improve the tropical cyclone intensity prediction. Next, we move to the data and methodology. So what we have done, we have taken recent 3 years, 2018 to 2020, and 17 tropical cyclone cases. And we have tried to look at different parameters of this. So one interesting thing in these 3 years were like it witnessed 2 supercyclonic storm, 3 extremely severely, and other categories of tropical cyclones are also. So all together, we got a very good data sets in all the categories of categories of intensity. So when we look at our other data sets, so as I said, an EPS model which has 23 members, we run Metofis TC tracker and get the parameters like the 10-meter winds, MSLP, and the location of the tropical tropical cyclonic system in terms of latitude and longitude. So we have corrected the model in 2 stages. First, we have corrected the mean of the intensity in terms of MSW and central pressure, and then we have corrected the members retaining the spread of those members. So this is a typical tactical process of any machine learning. Even you can see any statistical model also we use the similar kind of things. So suppose if we have a predictor Y, we find we have a response, we have a response Y and we have many predictors. So we try to find a mapping between Y and X, and we use different statistical.
John, you can go to your result. Actually, you have introduction. You have spent a lot of time. Quickly,
Yes,
you have got
yes.
only
Yes,
2 or 3 minutes. Quickly, result come.
Yeah, sure. I'm coming to that part. So 3 machine learning methods we have used, and the details you can find These are multivariate linear regression, random forest, and support vector regression. So next, we are moving to the results, and this is preliminary results, but these are very promising. You can see here I have shown the improvement in central pressures of our mean of our model. So in the left panel, this is the MLR, and the right side you can see the random forest machine learning technique. So what you can see, as I have highlighted uh, in the circle, this random forest method has done an excellent job, especially when the intensity was very high. So usually the model had underestimated, but after applying these machine learning techniques, the errors or the biases have reduced. But this was the case when we split the data in two parts. So 80% data was in training and 20% was in the test. Likewise, we have found interesting results for maximum sustained wind also. And here also I have highlighted that the improvement was very good, and especially over the higher wind side. So in the text I have highlighted how these models have reduced the mean root mean square error. So you can clearly see that the NEPS model, which has 19.2 knots of mean RMSE, has been reduced to 8.1 knot. Now, other way is like for any operational setup, we cannot split the data like this. We have to provide the forecast in real time. So we have tried to evaluate that part also. So this result shows the error in maximum sustained wind and central pressure for the case of supercyclonic storm Amphan. Here also we can see that both machine learning techniques, MLR and random forest, has reduced the error at all the forecast lead times. The reduction in MSW was more.
Please conclude.
Yeah, this is conclude. So we have looked at the ensemble members, and here you can see that day 3 and day 5 forecast of central pressure and MSW, and clearly you can see that blue color shown by the NEPS NEPS mean, and these are the lines which show the after the bias correction, and it is try to match with the best track which is shown in the black color. So this is the last slide conclusion. So as I said, machine learning techniques are very promising, and it can be used in an operational environment. When we club this machine learning technique on or we integrate this method on our NWP system, the only problem or the constraint we have that we don't have handcast data. So in the cases when we get something severe and it has not happened in past, then these ML or the data-driven models have some difficulty. So we can further improve or fine-tune these machine learning algorithms, and we can use other techniques also. Thank you.
Okay. Yeah, it's a nice effort to predict the intensity of a cyclone actually. Yeah. Dr. Ashrit, you have got a question, please.
Anand has some question, I think.
Yeah, Anand, you can.
Yes, thank you. Actually, it's a good approach, sir. Certainly, intensity prediction is a real challenge. But my question is that actually we do ensemble prediction to get the information about the chance of extremes.
Yes.
So why you will be needing this ML? Actually, then through ML, if we modify, then the NWP, what it is predicting about the chance of extreme, that will be modified.
That's fine. So for that sake only, I was discussing that we have applied these techniques in two parts. We have just tried to correct the mean, and we have retained the split also. So the intensity, the uncertainty, what you are talking about, we will get after the bias correction also. So we are not going to lose the uncertainty feature in this method. We are not correcting all the numbers in that fashion.
Okay.
Okay, we have to see actually that.
Yeah, definitely. So this is
what?
preliminary
Yeah,
results,
yes,
and we are
yes.
working on it. Definitely, we will. If you have anything, we can.
Because
discuss.
in climate change scenario, we don't know what will be the extreme tomorrow. So that is why we are running ensembles to get the information about the extremes, if
Yeah.
there is anything.
Yeah, in fact, it is quite difficult even to measure the intensity. Actually, observed, intensity itself is difficult, a lot of uncertainty. So anyway, it's a technique. Is a technique. Attempting is
Yes,
nothing
yes.
wrong actually. But even now, people operationally find difficult to even get real time exact intensity. A lot of uncertainty is there.
Yeah. So
Okay.
that.
So
Right.
that itself is a big problem. Indira, you have a quick question. Last question.
Yes, sir. Sushant, do you think the random forest is the best method to correct the bias?
Definitely not, ma'am. So in the future work I have mentioned, we are trying other methods also, but we have to control at certain point. So definitely we will tune these machine learning algorithms, and we will test a few more algorithms also.
Okay, and you told that you are training data set and the other data set. So the forecast data set. So that how much is your training cases? How many cases are there?
17 cases. We have divided our study into scenario. First was we have 33,300 forecasts. We have split it in two parts: 80% training and 20% test cases. And we have trained the model, and we have found the parameters, and then validated the model for test cases. In the other case, what I showed for Amphan, it was 2018 and 2019 data sets that was used for training, and we have individually tried to evaluate our model for each and every cases of 2020 tropical cyclones.
Thank
And
you.
one of those were Amphan.
Yeah, thank you, Dr. Sushant.
Thank
Actually,
you.
so both of you can discuss. Both are from NCMR WF only.
Yeah, yes, sure.
So because we
Yes,
have a
yes.
limited time, otherwise it would have been. I would have been happy to have more discussion on this. Okay, thank you, Sushant, once again. So
Thank
we
you.
will
Thank
move
you.
to the last presentation by Dr. Hazibur Rahman. Please share your presentation, and he will be making presentation on improved ocean analysis with upgraded model in the global ocean data assimilation system. To Hazibur Rahman.
Clearly, I'm not able to share, Dr. Sushant.
Yeah, can somebody help him? Yeah.
You can try it now.
Yeah. You
Yeah, it's
can
in.
now
Are you able to
project
see?
it. Yeah, you can make a slideshow.
Yeah.
Okay.
Okay, so
You can minimize the box that comes at the right side.
what is that?
There is additional something is coming, You remove.
Yeah, you can minimize that.
Yeah.
Minimize, or you can move to the top of the area.
Okay.
Okay,
Yes,
now
yes. Yeah, please come. Continue.
Yeah. So good morning to all of you. So today I'm going to present improved ocean analysis with upgraded model ocean data assimilation system. As you know, Invoice is providing the crucial initial condition for the. Yes.
Dr. Rahman, can you be louder,
please?
louder? Yeah.
Okay, so as you know, Invoice is providing the crucial initial condition for the CFS version 2 for the seasonal monsoon prediction. So this GODAS Global Ocean Data Assimilation System is abbreviation GODAS. It is being using this system. We are providing this operationally since 2013. So it is basically it was initially adopted from NSAP, and then finally we have many modification we did and operationalized in 2013. So next, okay. So as you know, if any operational analysis and reanalysis system, there is two components: major observing system as well as ocean model, and then data assimilation methods also required to that. So the key of this is ocean model. There is a physical model which is the driving force, and then we use some techniques to whatever the observations are there to rectify this initial error in that model. So these are all observations, as you know, from ocean altimeter by sea surface height, sea surface temperature, XBT, expendable belly thermogram, which is giving the subsurface temperature, Argo profiling for, which is since last 2 decades, it is giving the global subsurface temperature and salinity profile with very good accuracy.
and then CTD as well as mood buoy also are there, which are these are all observations are coming from this real time. So this operational ocean analysis and reanalysis, whatever product we are getting, this is mostly used for the seasonal forecast, whatever model to initialize that, and then ocean monitoring as well for different systems, different kind of monitoring system, and then also this INSO prediction. Basically, data assimilation, I already explained, this model plus observation, we are trying to make it more accurate initial conditions, and then this, if we are doing this for the past data, which is called the reanalysis, and when it is just giving the present today's kind of thing, it's called analysis. It's so at INCOIS, we are giving this analysis based on IMS-Delhi atmospheric flux, and using the model of MOM4. It is being developed by GFDL. It is 2005 version. It's being roughly 50 kilometers zonal resolution and 25 kilometer meridional and 40 vertical level. Atmospheric forcing we are using from INCOM, and the data assimilation method we are using the 3D bar assimilation technique. So parameter assimilator is temperature and salinity profile from Argo, XBT, and all sorts of whatever in situ platform we are getting. And we are also nudging this YSST in the surface SST. The outputs we are getting the temperature, salinity, surface height, and currents. So as you know, this is the present operational model is based on MOM4P0, which is basically a Z model. So this is only models kind of this slab kind. So there are other versions that came up. 2009 MOM4P1 is being released, which is kind of use this stage version sigma coordinate model. You know, this is trading following, and it is slightly modified in between these two, which is straight Z star coordinate model, which is mostly kind of in between mixing of these two. So I use this model to upgrade these GODAs. As you know, this as accurate initial condition will be able to give that more accurate forecast, seasonal forecast we can get. So the improvement in this MOM4P1 are tremendous. This special base most important is the vertical coordinate system, which is being used in this Z star instead of Z. And apart from that, other crucial parameters, which is parameterization scheme, are being physical parameterization schemes also being improved, updated. One most important parameter is Simonson and Lee tidal parameterization schemes, which is used for mixing in the subsurface. And also instead of two-band optical penetration, this being used three-band system, as well as many other advantage in this model is there. So I use this model to upgrade this. So before that, what are the platform we are using for this observing platform in the available in the global ocean? They all pretty little bit go. Yes. Are you able to hear me?
Yes. Please continue.
Yeah, so this is these are the all sorts of platform which is giving this surface as well as surface data. One of the most important is the Argo profiling float, as it is being planned for the 3 by 3 degree resolution and over the global ocean, which is maintained 100% since late 2010 onwards. And this is maintaining as of now. If you see these different platforms which are giving the data, it is roughly more than 9,000 probably now, and more than half of these NOAA is maintaining. This is comes under GCOS, Global Climate Observing System Plan, and these are all these data are utilized, but the most of the all operational centers across the world to assimilate these different data sets into the model. So coming to the results, as you know, what is this? This is with three experiments we did. One thing is as even today also, you know, NCEP is using the observed temperature and synthetic salinity only for their analysis based on MOM3 even today. So now what we did is we used three different experiments we did. We used the observed temperature and synthetic salinity into the older version, which is called P0 synthetic salinity, and another one just upgraded this model with this P1 version, same synthetic salinity. And final another one experiment we did with the both observed temperature and salinity. You can see the tremendous improvement in this. What you see is zonal current RMSE. This is with respect to Oscar current. You can see the drastic improvement in the P1 when you are going from P0 to P1. Further, when you are going to the actual salinity observation, actually salinity assimilation, which is further reduced only around 20 to 30 centimeter per second compared to 40 to 50 centimeter in that. Coming to the correlation, even the vertical zonal and meridional current also has drastically improved. This is the correlation, and this is the RMSE error in the zonal current at the 90 DCP. You can see also the correlation also improve in this. There's a right lower panel, right panel shows this mean sea surface height from altimeter, and this is the difference between these two. This is the older version, and if you go to the next version, which upgraded version, drastically improved. It is 4 to 6 centimeter, while it was 8 to 10 centimeter, almost half. And further, it is importance of actual salinity assimilation also demonstrated here. It further reduce the this RBC difference here, mean difference. So correlation, if you see the sea surface height anomaly correlation, also it is being improved in P1 compared to this P0D. And further, many actual salinity observation we are assimilating, further it is improved. It is RMSE also, this similarly it is being improved. So coming to, as one of the biggest challenges, any ocean analysis, reanalysis system to independent validation of data, which is most of the data is being assimilated. But fortunately, we have this CTD observation from the two process in 2003 and 2009. If you see the comparing this with the actual salinity and temperature from that cruise data with this analysis, you can see this with this new version and about actual salinity and temperatures assimilation, it is going one-to-one with the observed data from the CTD. Both in 2009, it is in July, August, and it is in October. So it shows that how this just only one model improvement can improve the ocean analysis. So one of the biggest improvement in this model things is we found is this thermal inversion in the northern Bay of Bengal. It is often in the winter time, you know, this northern Bay of Bengal, this is cool temperature. This is TMI observation in December 2011. This is observed. This is from the older version, operational one, which is based on P0D. It is not able to capture. Mind this, all this data, all these simulations are based on NCF reanalysis 2 forcing. So now, if you just upgrade this model with P1, it is being TMI observation. It is close to northern Bay of Bengal. Cooler SST is coming. Further, if you are again assimilating the actual salinity, it is further close to TMI observations. Now it is the independent subsurface observation. If you see the from buoy observations, the red color from P1, and this that means the salinity, actual salinity assimilation is playing a major role, which is actual salinity only is able to capture this inversion, which is seen in the buoy observation. Now further, if you see this is showing the three different Argo observed data, readed data shows the thermal inversion in the northern Bay of Bengal in 2011 December. The script Argo and all this is showing this inversion of 2 to 3 degrees centigrade in the northern Bay of Bengal. Now coming to the analysis, if you see the older version P0, it doesn't capture this thermal inversion at all. Now when you just improve, just changes the model, it is being started coming, and when you are actually assimilating the salinity, it is very close to the data. Of course, there is a slight differences there, even in different data sets as well. But however, still it is giving the northern Bay Bengal thermal inversion very accurately. So these are all analyses based on
Dr. Habibur, can you conclude now your time?
So I just another two slide. I'll just finish.
Yeah.
So this is operation one, which is using this global. This is from ENCOM. This also we use this forcing and see how this is similar and improvement we see. Particularly the SST. If you see the SST in different region, this is the time series in 2015 and 16 with compared to IMS-Delhi SST. You see this CODAS P0D, which is the operational one, is not able to capture these high peaks, which is with the improved version, it is we are able to capture it. Similarly, with KeyJet as well, it is we are able to capture this mine. So INCOIS is also showing this oil spill trajectory based on oil spill advisory, which is also in this global forecast being used for this advisory in 2017 enrolled oil spill event, and it was very accurately predicted, and it was means appreciated by the Coast Guard. And these are the present operational reanalysis and analysis system is available throughout the global, which is giving this mostly all the centers. And coming to the summary, as I already informed this, we have updated this present operational quotas with the newer version with the more sophisticated physical parameterization scheme. Independent observations is being used for evaluation this analysis, and it is shown this all sea surface temperature, subsurface current, then sea surface height, all are drastic improvement in this. And most important part is this thermal inversion is coming in this analysis, which is not present in the older version, and with KJet as well is we compare very good. So thank you for your kind attention. Any question?
Thank you, Habibur. You have got a question from Gibis saying, do you assimilate any satellite-based ocean observations?
Yeah, actually, now I am working on this assimilating the altimeter sea surface height. It is being already done. So it is this paper is under preparation. So we have implemented this in altimeter assimilation. It is being improved as well further with this.
So which are those observations actually? Satellite.
So, satellite altimeter based sea surface height anomaly.
Okay. Anybody else have any question? Anybody else? Okay. Yeah, Habibur, actually, you have done this simulation from 2003. Am I correct?
Yeah.
Yeah. So we had we had requested earlier to that data to go back to at least up to 1993, so that we can prepare to match with the NCMRWF initial conditions, atmospheric conditions. So is there any progress in this regard?
Yeah, actually, in this new version, I did some experiment. It is being already, but it is not yet ready. I mean, it is being. I made it, but it's not this operational one. We are finding to upgrade this with this newer version or some other version. If it is newer version, it will be available on that from 91.
Okay. Yeah, and another thing is there was effort from IITM and INCOIS to develop coupled, data assimilation. So, is there any progress in that case? What will be status of ocean assimilation? Is it required then?
Of course, OCD is required, but I am not aware about what is the development is going on. I am not. I don't know anything about that. Probably
Okay,
you
because
will.
coupled data assimilation. In that case, you will have both.
Yes, I'm fully aware about this, but I don't know what is that status and what is going on and now.
Okay, fine, Hasibur. Thank you for a nice presentation. Dr.
Thank you.
Abhilash, you are there? Dr. Abhilash?
Yes, sir.
Dr. Abhilash, you
Yes,
can
sir.
have,
Yes, sir.
yeah, if you can have a quick 1 or 2 minutes, which you had lost that time, you can quickly
Yes, sir.
use. Just you can, Okay, Anand, it's okay, no? 2 minutes, yeah.
No issue, sir.
Yeah, Abhilash, please.
Sir, actually, these 5 days, I think this was the last slide where I lost my connection. These 5 districts are from Eastern Agroclimatic Zone of Haryana, and this region has a dry subhumid climate and receive higher rainfall and have assured irrigation facility. And rice, being a high water requiring crop, is grown during Kharif season in these districts. So there was not much impact of rainfall on rice productivity in these regions. These 5 districts in which Bajra is grown are from Western Agroclimatic Zone of Haryana. And the climate of this region is arid to semi-arid, which receives less rainfall and does not have any assured irrigation facility. So crop production is mostly dependent on onset of monsoon rainfall. And pearl millet or bajra, being a less water requiring crop, have shown a typically positive response of monsoon rainfall on crop productivity during Kharif season. Now, this figure shows the deviation of crop productivity during El Nino and La Nina years from neutral years for rice in Eastern Agroclimatic Zone and bajra in Western Agroclimatic Zone. From first figure, it can be seen that the rice productivity during both El Nino and La Nina years have decreased at 4 districts out of 5, but decrease in magnitude is also very small as compared to the decrease in bajra productivity during El Nino years. This decrease in rice productivity can be attributed to decrease in rainfall during El Nino years and physical damage to crop in case of excess or heavy rainfall events received during La Nina years, particularly in the month of September when rice is at the harvest stage. But in case of bajra, an increase of around 20 to 30% was observed in crop productivity during La Nina years when rainfall was higher as compared to normal years. And In conclusion, it was seen that a general decreasing trend of monsoon was observed in 16 out of 22 districts, but statistically significant decrease was observed at only 2 districts, Kurukshetra and Panipat. And high variability was in the district lying in western agroclimatic zone of Haryana. And there were significant correlations between ENSO and monsoon rainfall. And impact of monsoon rainfall was observed on Bajra. ENSO was observed on Bajra as well as rice productivity. And this analysis can be helpful for policymakers and planning makers for water resource and at district level. And the climate change impact can be studied for other states also, like Uttarakhand, Punjab, or Himachal Pradesh, which are adjacent to Haryana. Thank you, sir.
Okay, this bajra is a kharif or
Yeah, both
Rabi?
are kharif crops, sir. Actually,
Okay.
bajra is a drought-resistant crop. So basically, in western agroclimatic zone of Haryana, there are no assured irrigation facilities. So mostly the crop depend on the onset of monsoon. Like if monsoon reaches at 15th July, then only its sowing will be done. Before that, the farmer usually wait till the monsoon is arriving.
No, how come that La Nina of extreme rainfall, heavy rainfall during La Nina is spoiling rice, but bajra is okay with that? It is in
Sir,
fact
actually, in eastern agroclimatic zone of Haryana, bajra crop is not sown, so that impact was not seen here. But I'm just saying that in case of rice, when
okay.
the crop productivity is decreasing, but the magnitude of decrease is quite small. So in that case, the rain, the increase in rainfall was seen in September month. In case of La Nina, so
Okay.
this decrease can be attributed that if there was any heavy rainfall event in case of La Nina, then the productivity might have decreased because rice is usually at harvesting stage or
Oh.
at near physiological maturity.
Okay. Okay. Thank you, Abhilash.
Thank you,
So
sir.
I thank all the presentation, those who have presented, all the 6%, they remain within the time, and we could complete almost on time. Thank you all. Back to organizers.
Thank you very much, sir.
Thank you, sir. So you completed the session. We are a little late, but in time actually. Thank you, sir, to organize the session so nicely, as well as I thank all the presenter to present their work, and those are all valuable works. And we'll be following these research results so that in operation we can improve. So thank you to all, and thank you, sir, again.
Thank you.
And announcement is there. Next, actually, there is a poster presentation session. So that will be available in Hall A. So we can, Hall B will be closed. So we can join again there in Hall A for poster session. So after just 5 minutes from now. Yeah.
Okay. Thank you, Anand. Yeah. Bye.